Hi, welcome back. Today we're going to look at section 2.6, which is on instantaneous rate of change in interpreting graphs. So, almost 2 pages of these notes are a lot of your concepts and definitions, so we're going to look at that and just make sure they make sense to you. So up at the top of the notes, it tells you to determine the rate of change of an object at an instant when t equals a seconds. We need to analyze the average rate of change, delta d over delta t, okay, so distance over time, for smaller and smaller values of delta t. That is, we want delta t to approach 0. In this lesson, we will use tables to introduce this concept. So keep in mind that when we were doing limits, okay, this all revolves around these limits we were finding, that we were trying to find the value as x approached some value, right? And if you remember in the tables we used, we kept letting those x values get smaller and smaller, or get closer and closer to that number we were looking for. So this is that same concept, okay? Except now sometimes we're going to be looking at not just x, but in terms of real life situations, what these values represent. All right, so let's look at some of the objectives and then some of your concepts and definitions. So today what we're going to look at is finding the instantaneous rate of change, and then we're going to interpret the graph of a function. Okay? All right, so first one. Number 1 says the average rate of change, delta d over delta t, is approaching the instantaneous rate of change of d with respect to t as delta t gets closer to 0. Okay? So the average rate of change, which remember, it takes 2 values, right? We're trying to get those 2 values almost together. Once we get them together at one specific point, then that's going to be what we call an instantaneous rate of change. Okay? So average rate, we already have been doing that. We did that in the last couple sections. That's just the formula for slope, right? y2 minus y1 over x2 minus x1. Okay, or in this case, it would be d2 minus d1, the distance, over t2 minus t1, the times. So it just depends on what values you're using in the numerator and the denominator. Instantaneous, if you're asked to find the rate of change at one point, then we need a new formula because we don't know how to do that yet, okay? But we're trying to get as close to approaching 0, where the difference between these two numbers are nothing, okay? There's no distance between them. All right, so the instantaneous rate of change of distance with respect to time is called instantaneous velocity. So when we start doing problems with words and real life problems, when we're looking for an instantaneous rate of change of these, we'll also be talking about velocity. Okay, so just keep that in mind as we move forward. All right, number 3 says the average rate of change is a numerical interpretation of delta y over delta x, change in y over the change in x, which is the same thing as the slope of the line between the 2 points. So that's what we were working on in past section, right? We knew that we were finding the average rate of change is the exact same thing as the slope. All right, a line that goes through 2 points on a graph is called a secant line. Okay, keep that in mind. A line that goes through 2 points on a graph is called a secant line. The slope of this line equals delta y over delta x, which is the same as the average rate of change between those points. Okay, so we did that in the last lesson. So just quickly, if I had a graph, let's say a parabola, and I put 2 points on that graph, okay, and you found the slope of that line that goes through those 2 points. So that line is called a secant line. It goes through 2 points on a graph. Okay. The average rate of change of this line through those points is the slope of this line. Okay, that's what we've already done. Okay, so that's an average rate of change. Average always means between 2 points, right? That's what an average is. All right, so let's look at the next page. Number 5 says, a line that touches a curve at exactly one point is called a tangent line to that curve. Okay, so again, same parabola, or as close as I can get to what I drew on the last page, okay? But if I only gave you one point, okay, and I asked you to draw a line that just touches there, that line would be right here, right? That's called a tangent line. It only touches the curve in one point. Okay, the secant line was 2. Well, the secant line, if I had 2 points, I could find the slope. I could find the average rate of change. But how do I find the rate of change right here at one point? Okay, that's called an instantaneous rate of change, and I have to use something a little different for that. So number 6 says the slope of a curve f of x at a point AB is exactly the slope of the tangent line to the curve at that point. This is called an instantaneous rate of change. Okay? So please keep in mind today, and when you're doing your homework, if it asks you for the average rate of change, we've already done that. That's the slope formula, the y2 minus y1 over x2 minus x1. But if they ask you for the instantaneous rate of change, this is what you have to do right now. This is all we're going to know how to do is number 7. So numerically, the slope of the tangent line is given by dy over dx, which equals f prime of x. Okay, we're going to talk about that in just a second, but it is the limit as delta x approaches 0 of delta y over delta x. Change in y over change in x. That's still true. However, since we don't have 2 points, we're going to use this difference quotient. Remember, we've already done this. The limit as h approaches 0 of f of x plus h minus f of x over h. This only needs 1 point. Okay? Now, dy dx, dy over dx, or f prime of x, is new notation for some of you if you've not had calculus before. These are the notations for derivative. Okay? Either one of these is fine. Derivative can be denoted as dy over dx or f prime of x. Okay? So when you see these notations, either one of these, that means that's the derivative. Okay? So the derivative is denoted by either one of those and is the slope of the tangent line at a point, whatever the point is, x comma y. The derivative also means instantaneous rate of change of the function at x. That's hugely important, okay? The derivative, okay, is the slope of the tangent line, and it's also the instantaneous rate of change. Those are all the same things, and that's real important that you understand that moving forward. Calculus is all about derivatives, and so you really need to have a good understanding of what that is. Okay? So, if you're asked to find the rate of change at a point, at one point, this is what you use right now. Okay? If you're given 2 points, then you can use your regular slope formula. All right, and then number 9 says, for an input x equals a for a given function f of a is the height of the point, and f prime of a is the instantaneous slope of the curve at that point. Okay, so go back to that picture that we had. Okay, if I give you the function value, let's say, just looking at this point, let's say f of 2 equals, I don't know, let's call it -3. Okay, let's say we went over 2, down 3. Okay, so -3 is the height. Okay, that's how high up above y or below y it is. But if we did f prime of 2, if I told you that was 6, then that's the slope of this line right here at x equals 2. Okay, that's the slope of the tangent line. So that's what this number represents, the slope of the tangent line at 2, or the instantaneous rate of change at 2. Okay, that's what number 9 says. It says instantaneous slope, same thing, rate of change. Okay, okay, so not a lot of practice problems in here, just making sure you understand the notation and doing some of this work. So these first three problems are pretty quick. We're just going to interpret meaning, making sure you understand. So for number one, you're given a curve, okay, a cubic function. F of x is 4x cubed minus 3x squared plus 7x plus 1. Okay? If you were to graph that, not that you need to, it looks something like that. Okay? So it wants for you to interpret the meaning of f of 5 equals 461 and interpret the meaning of f prime of 5 equals 277. Just in your own words, how would you write what that means? Okay? So this is a function value, ordered pairs. Okay? So on a function, okay, this says that the height of f of x at x equals 5 is 461. Okay? So in other words, over here 5, 1, 2, 3, 4, 5, way up here is 461, right? That would be the ordered pair. So when x is 5, the height, how high it is 461. It's also the function value, right? That is the ordered pair 5, comma, 461. Right? That's what this represents. Okay? So what is the meaning of f prime 5? That's the derivative of 5 is 277. Okay? So that means the slope of the tangent line at x equals 5 is 277. Okay? And you can replace slope with the instantaneous rate of change. Okay? So same thing. The instantaneous rate of change of the tangent line at x equals 5 is 277. Those mean the same thing. Okay? So you can write it either way. Just make sure you understand those are the same thing. Slope is not average rate of change for the tangent line. It is instantaneous for the tangent line. For secant lines, it is average for 2 points. Okay? So again, if you looked at the tangent line at that point, it might look something like that. It's a very steep line, right? So the slope of that tangent line, the rest of the curve, but the slope of that tangent line would be 277. Okay? All right, let's try it again for number 2. Interpret the meaning of f of 3 equals 14 and f prime of 3 equals 7 for this function. Okay? Well, this function is a parabola. Looks something like that. Okay? And so we're looking at when x is 3. So 1, 2, 3. Somewhere up here. Right? Okay. So what does this mean? That's the ordered pair. That means when x is 3, the y value is 14. So that is the height of the function, right? So the height of f of x at x equals 3 is 14. That's what f of 3 equals 14 means. Can put that in there, okay? So f of 3 equals 14 means the height of f of x at x equals 3 is 14. All right, f prime of 3 equals 7 means what? Okay, again, this is derivative, and derivative is the instantaneous rate of change or the slope of this function when x is 3. Only when x is 3, because if I have a different point, the slope is going to be different. So this means, right, the slope of the tangent line at x equals 3 is 7. Or again, the instantaneous rate of change of the tangent line is 7. So again, the tangent line would be somewhere around here. So we're just saying the slope of that line is 7. Okay? And don't forget, slope can be interchanged with instantaneous rate of change. The tangent. And I say that because it's not, again, slope is not the average rate of change. Okay, it's instantaneous when you're talking about one specific point, when you're talking about a derivative. Anytime you're asked to find a derivative, it is of one specific point. Okay, that's instantaneous. I've said that a lot today, so hopefully that's sinking in. All right, number 3. Suppose that f of x represents the total number of townspeople that have rented a certain movie, and x is the number of days since it came out. So now we're talking about, in real life, let's put some words to this. So x is the number of days since the movie came out. F of x is how many townspeople have rented it, right? So what does f of 13 equals 200 mean? Okay. That means 200 townspeople rented the movie 13 days after it came out. Right? That's what that means. Okay? That's a function value. So 13 days after the movie came out, this is how many townspeople had rented it. All right, part B. What does the derivative f prime of 13 equals 17 mean in respect to these words, okay? So what does this mean about the townspeople and the number of days it came out? Okay, so this is the rate of change at this value. So I would say 17 is the rate of change in what? Okay, is the rate of change in townspeople who rented the movie after 13 days of it coming out. Okay, so 17 is the derivative. That's the rate of change in townspeople. That's what that is. 13 days after the movie came out. But that is just then. So f prime of 14 is going to be a different number, not the same. Okay, this is instantaneous. It's the rate of change at specifically 13 days after the movie came out. Not 12 days after, and not 14 days after. 13 days after. All right, number 4 says, use a graphing utility to find the slope of f of x equals the square root of x at the point 4, 2. Round your answer to the nearest hundredth. Now you're really just using your calculator because you're going to get some decimals here. So you guys will probably have a problem similar. Okay, so let's look at that. Okay, so in your calculator, go to y equals and put in the square root of x. So under y1, you're going to put in square root, okay, second square root, and then x underneath it. That's it. And then let's graph it. Okay, so I'm going to graph that on my paper so I can write on it. All right, so here's the square root of x. And it says we want to find the slope of this function at that point exactly. So 4, 2, right there. So when x is 4, y is 2. That would make sense. When x is 4, the square root of 4 is 2. All right, so that's that ordered pair. All right, so if I want to find the slope at this point, okay, I need to look at the specific value for that at that point. So we have a limit, okay, find the slope Let me go back to my piece of paper right here. Okay. So we're going to do f of x plus h minus f of x over h. Okay. All right. So let me write that down, and then we'll substitute in what we got. So we're going to do the limit as h approaches 0. Now finding the slope, so that's the derivative of f of x, so f prime of x. So the limit of f of x plus h minus f of x over h. Okay. All right. So we want to find the derivative at 4. Right? So we're looking at f prime of 4. So we got the limit as h goes to 0. All right, so we're going to do f of 4 plus h minus f of x. F of x is the y value, so minus 2 over h. Okay. All right, so remember what this means. We're going to substitute in this for x. All right, so now we have f prime of 4 is the limit as h goes to 0 of, instead of the square root of x, we're going to put the square root of 4 plus h minus 2 over h. Okay. All right, so now I'm going to let, now I've got to do, I got to rationalize. I got that square root up there. So remember we did those. This is good practice for that. So I can't plug in 0 right now because I'm going to get 0 in the bottom. But I know I'm going to get an answer. Okay. So I'm going to plug in and find the conjugate. So I'm going to multiply the top and the bottom by the conjugate, which is square root of 4 minus h. Sorry, square root of 4 plus h plus 2. Right, change the sign in the middle. Did that wrong. All right, so use the conjugate. And what will that give us? That's the limit as h approaches 0. Remember in the top, you just have to do the first and the last. You don't have to do the outer and the inner. They're going to cancel out. So square root of 4 plus h times the square root of 4 plus h is just 4 plus h. And then negative 2 times 2 is minus 4 all over. And then you leave the bottom just the way it is, h times this. Remember, you don't have to do anything with the part that's not the conjugate, right? All right, so f prime of 4, limit as h goes to 0. Okay, what happens in the top? We have 4 minus 4, so all we have is h in the top. And in the bottom, you have h over square root of 4 plus h plus 2. Okay, now the h's cancel out. So now we have the limit as h goes to 0, 1 over the square root of 4 plus h plus 2. Now you can substitute in 0, because I'm not going to get 0 anymore. So if you plug 0 in now for h, you get 1 over the square root of 4 plus 0 plus 2. Square root of 4 plus 0 is the square root of 4 plus 2. Square root of 4 is 2. 2 plus 2. So you end up with 1/4. All right, so that is the slope of the tangent line. Okay, this tangent line, and the line that just touches right there. And it says round your answer to the nearest hundredth, so that is 0.25. If you're going to write it as a decimal, same thing. Okay. Fine to leave it 1/4, but if it asks for decimal, then decimal. Okay. All right, so if you're looking for instantaneous, 1 point, you got to use that limit, the definition of derivative, which is that limit formula, the difference quotient. Okay. All right. I want to look at one more problem with you, only because I want to make sure you're okay with your homework. Okay, so it's similar to what we just did. Okay. So I'm going to add a number 5 here. Okay, and it says find the slope of f of x equals 3x minus 2 at 3, 7. Okay. All right, so again, if I'm only finding the slope at one point, then I need to use the derivative definition. So to find the derivative, which is the slope, we're going to use this formula. Okay, so it's important you need to know that difference quotient. The difference quotient is just this piece, but when you do the limit as h approaches 0, that's giving you the derivative. Okay, that is the derivative. So what are we finding? We want to find the derivative at when x is 3. Okay, so we would find f prime of 3, which is the limit as h goes to 0, so x is 3. X is 3. Okay, so f of 3 plus h minus f of 3 over h. All right, so let's fill that in. All right, so f of 3 plus h means replace any x in your problem with 3 plus h. So that would be 3 times 3 plus h minus 2. Okay, that's what that first part is. Then it says minus f of 3. Well, f of 3 is the function value. They gave you that, 7, so minus 7, all over h. All right, so that, if we simplify it, distribute out the 3, so that's 3 times 3 is 9. 3 times h is 3h. Minus 2 minus 7 is minus 9. So now, simplify that. The 9's are going to cancel out. So we're left with 3h over h. So you can cancel the h's, and we end up with just 3. We don't have to put 0 in there. There's no h's anymore. So the derivative, or the slope, of f of x at 3 is 3. Okay? So that just happens to be that same value. So again, just making sure, instantaneous, got to use this. Average rate of change, that was what we did last time. That's just the slope formula, right? The y2 minus y1 over x2 minus x1. So pay attention to what you're asked for. Pay attention to how many points you're given. Okay? All right, so work on your homework, and then let me know if you guys have any questions.